So now that we've applied boundary conditions, now we're ready for the next step to solve the resulting linear algebra problem. In our last video, we came up with this system of equations. Remember, we're looking at vectors and matrices, but remember that this also relates to a system of 8 equations with 8 unknowns. I had already indicated that the way we will break this up in this our solution into 2 subproblems. First, we will solve for our unknown displacements. Once we have those unknown displacements, we'll find our unknown reaction forces. To solve for our unknown displacements, I'm really looking at a much smaller problem. This 2-member vector, u1, v1, multiplied by this little 2x2 matrix is equal to this 2x1 vector. Rewriting this smaller system, just taking this little matrix, rewriting it, my displacement vector and my force vector, I now see that I have 2 equations with 2 unknowns, u1 and v1. I can solve for that. I can solve for that using substitutions. This is a simple 2x2 system. I can use a calculator. I can use MATLAB. In either case, we don't need to go through how to solve for this 2 unknowns. The answer ends up being 0.414 times 10 to the negative 2 inches in the x direction, and a displacement of negative 1.59 times 10 to the 2 inches in the y direction. Now, before we go on, we should take a look and see if that answer makes any sense. Remember our system. We have 3 bars. We're looking at node 1. I have a force applied in the negative y direction. I have immovable points here. Does it make sense that my y displacement for this node, for node number 1, would be in the negative y direction? I think it does, because I've got a force pulling it down. It's a little less clear if, in fact, my displacement in the x direction really would be this way, but it seems to make sense. So far, we seem to be in pretty good shape. All right? So now I know my displacements. That was actually one of the things I was asked for. So again, I should probably put a box around that if I want full credit on my homework to make it easy to grade. And now we're ready to move on to the second thing we were asked for to find in our problem, the unknown reaction forces at the various nodes, or where that are at elements where I've got immovable boundary conditions. Okay? But this is fairly simple, because now I have a matrix which I know multiplied by a vector. So now this is not solving for unknowns. This is simply taking a matrix and multiplying it by a vector, which is a very easy mathematical calculation. It's even easier by the fact that most of the elements in this matrix are 0. And if this is a 0 in the 3rd row of the vector, that means this column is going to get multiplied by 0. This column will get multiplied by 0. And all of these columns will get multiplied by 0, except for these first 2 columns. So I can solve for my force vector. I have my 2 known values. I'm just going to take the u1 value, which I now know, multiply it by, don't forget to multiply it by this 500,000 we have out in front, times this vector, plus the v1, which I know, don't forget to multiply it by that 500,000, times the second column in my matrix, is equal to the force vector that I'm trying to find. So this is all the forces in the x and the y direction at all 4 nodes. Again, this is something I was asked to solve for. I should probably put a box around that. Also, this is a good check to see if we've done our work correctly. We know our system is not moving after this force is applied. Therefore, all the forces acting on all the nodes must add up to 0. And in fact, you can see that these 8 force components do in fact add up to 0, and they should add up to 0 all in the x direction and all in the y direction. All right, so that solves our solution part of our linear algebra problem. We still were asked to find one more thing. We were asked to find the strain or the stress in each bar. That we'll leave for the analysis step, which will be our last step for solving this problem, and we'll take care of that in the next video.